Hello, hello. This is Mr. Vaughn with video lesson 6.7, chapter 6, lesson 7. We're going to be simplifying expressions. So get your Cornell notes all set up there, and you'll want to be in your California Math book, page 495 to 497. We're going to be doing a few things out of there. So let's talk first about some vocabulary that we need to know. This is on page 495. So some of these you've had before. Some of them are going to be brand new. We talked about the word term last week. A term are numbers separated by a plus or a minus sign. So here in this example that they give there, there's three terms because we have this, and it's separated with a plus sign from this, and this is separated from a plus sign like that. So we have three terms here. Now you might be saying, well, what about 3 times x? That's, like 3 times x. That's not considered that is one term. They are not separate terms. So this expression right here has 3 terms. And so that's going to be referred to quite a bit. In addition to that, these are probably new words to you. The term coefficient and constant. So a constant is a number. Where are we? Right here. A number factor that. And let's go to constant first. Sorry, I like doing that one first. The term without the variable is called the constant. So in this example right here, the 7 would be the constant, because it does not have anything a variable with it that is 7. That's always going to be 7. And then the coefficient is a number that it's the number that goes with the variable term. So not the 3x isn't the coefficient. You would say the 3 is the coefficient here. Down below, the 9, would that be a coefficient or a constant? That'd be the constant, because it's going to be 9 no matter what. And then here, the 4 and the 2 would be called coefficients. Let's go ahead and go to the next page. Move right along here and get caught up on some notes there. Let's go with blue today. So we'll go 4x minus 7. So I would draw this out and label it so you have it in your notes. So 7 is the constant, and the 4 is the coefficient. And if you want to label yours a different way, that's fine, just as long as you have that information there. So there's your vocabulary background. Simplifying expressions. So what you do when you simplify expressions is you combine like terms using those properties that we talked about last week. I gave you some superpowers, and now you're going to put those superpowers into use. So take a look at page 496. We're going to do some of the examples that they give there. Let's do example number 1. Simplify the expression 4 times 6 times x. All right. So you got to kind of examine it and see what can you do with this. There's no addition on here. This is 4 times x times 6 times x. So it's all multiplication. So you can use the properties on it that you need to. So you want to combine like terms. This is all one term because it's not separated by a plus or a minus at all. So you can stretch this out, and pretty soon you'll be able to do this just in your head. You will be able to look at it, but I want you to write these down like this for now. So this is what it means, right? 4 times 6 times x. Now we can move the parentheses around according to the associative property, right? I can move the parentheses over here, where I'm not doing the 6 times x first. I'm doing the 4 times 6 first. And 4 times 6 is 24. X, that's as simple as it gets. So that's as simple as you can get when it's a simplifying expression. So the answer to the first one is 24x. Take a look at the got it problems. Let me go back over here. So if you didn't understand where we were, this was the problem I just did as an example. We're going to skip this one and to skip B and go to C right here. So that's why I'm going to write example C. So 7x plus 8 plus x. So what you want to do is you want to look at these and say what things are alike. Well, I've got two numbers that have, or two terms that have variables. I've got the 7x and I've got the x. So those can go together. The 8 is a constant. It's a separate term from the other thing, so it can't be combined. So what you would do is use the associative property to rewrite this, or I'm sorry, the commutative property to rewrite this, changing the order, right? So now it's 7x plus 8. Well, we don't know what x is, but it doesn't really matter because we have 7 of them, and then we have one more. So 7 plus the one more would be 8 x's plus 8. And so that is as simple as that can get. When they say simplify this, that's what they mean. Combining like terms using the properties. You rearrange them, manipulate them to your advantage. You can do that in math, don't do it to your friends. But manipulate them to your advantage so that you can combine them, the ones that are alike. Alright, on page 497, they give you some examples that have more than one variable, not just an x, but an x and a y. I'm going to go to a different color. So now we're looking on 497, example number 3, 14y plus x plus 22y. Alright, so you might look at that and go, wow, Mr. Bond, that looks like some crazy stuff. But it's not. Just dissect it a little bit. Look at it. So we've got these 14y plus x, that's in parentheses here. It's an addition problem in the middle, and then we add it to this. So I know, because of the associative property, I can change the groupings of this because it's all addition. So let's do that first. We're not going to touch the order. We're just going to change the groupings. I'm sorry, we are going to change the order. I'm going to get rid of their groupings because that grouping doesn't matter. So we're going to get rid of the grouping and then reorder it using the commutative property. Commutative. I always want to put an N in there, but it's not. It's a commutative. So we're reordering it. Okay, they did a little bit different, but it's fine. So in the book they have these things flip-flop. The x is first and then the parentheses are next, but it's okay. Alright, so what did we do? We dropped the groupings, we reordered it, we grouped it again, and now we combine like things. Okay, so these things are y's. The 14 and the 22, they're with the y's, so they can actually go together. The x, we can't put those with the y's because it's a separate variable. We don't know what it is. We know that the y's are always going to be y's, and they'll be the same. So 22, you can add 14 plus 22. You're adding the coefficients, right? And you end up with 36y. The x, there's nothing else for it to combine with, so that is as simplified as you can get. Sorry, the textbook did it the other way around. Either way should be fine. Alright, so that's a little bit about simplifying expressions. Remember, combine like terms. You're going to hear that a bunch. It means combine things that are alike. You could have 10 different variables in there, A, B, C, D, E, F, G, and you can put all the C's together, all the D's together, all the A's together, and all the constants together. We didn't do that in any of the examples, but like up here where this 8 is, if there were other constant numbers, you can add them together too. I think that is it for now. If you want some extra credit, stay with us. Oh, I forgot to tell you the joke. What kind what's unique about a mathematical plant? A plant like that would grow on the ground. What's unique about a mathematical plant? It has square roots. But I'm bumped. Right? Alright, if you want to stick around, do the extra credit and some extra practice, you can. I will put the answers up there. Otherwise, I will see you tomorrow. Okay, 496. We've got those there. Give them a try. See how you do. We'll turn it off, and then go down below. There's a word problem down here. Simplify expression for the total cost of 6 friends to go to the museum if only 4 friends view the mummy exhibits. So you're going to write that expression there. I'm not going to take the time to go over it, but there you are. And it'd probably be a really good idea to do some of the examples on the 2 variables. Let's go down to, there we are, down at the bottom, 497, E, F, and G. Pause the videos, do those, and then here we are, coming back. Here's the answer to E, F, G. There you are. If you have trouble with those, take another look at them, see if you can figure them out, or ask me about them tomorrow. All right, bye-bye.